anybody tell me what the Pythagorean theorem is? How does it go? Morgan. And a little bit more enthusiasm. A squared plus b squared is c squared. What do you think, Mr. Jacobson?
That's what I had.
That's what he had too, so yeah, at least tied it. But you guys got to answer first, so good job with that. Now, what the heck does it mean? Is that something with a circle? What in the world does the Pythagorean theorem have to do with anything? Caleb? It's in triangles, so will it work on this triangle? What do you guys think? Will it work on that triangle or not? And if not, why not? Daniel?
Not really, because they all have equal size.
Well, what do I have to have for it to work then? What's going on with that? Okay.
You have to have a right angle.
It must be a right triangle. Not just any old triangle. So let me put a right triangle up here. Okay, and then A, B, and C, what do they have to do with the triangle? Are they the angles, or what do I need to do with those? Where do they need to go on my picture? Melissa?
A, B, and C are all the sides of the triangle, and the C is the hypotenuse of the triangle.
Excellent. The one that they're the sides, and the one we have to be careful of is C must go on the longest one. And Melissa remembered the correct word, hypotenuse for that. It is always across from the 90-degree angle. And the other two, it doesn't matter which one is A and which one is B, but the one that is by itself must be the longest one. So let's get this written down. Come back and do the proof in a moment. Let's get this written down in your formula list so it's that nice handy piece of paper to review right before a test so you're not just hunting through your notes all over the place. It must be a right triangle. We must have that right angle in there, and C must be the hypotenuse, the longest side, the one that is across from the 90-degree angle. And then, because you guys are Algebra 2, we're going to actually prove this, because that's how smart I know you guys are, that you can follow and understand a proof. It's going to be based on geometry and on what you see when you look at the picture. So I think you'll have no trouble at all following it, but it's kind of fun to say you have learned a way that you can prove this thing. So, proving this thing now. Does everybody see a big red square? And how do I get the area of a square? Everybody just shout out, what do we do for a square? So we're going to do base times height, but if it's a square, the base and the height are the same. So the area for my nice big square simply needs to be one side times that same side. And who can tell me with letters, because I don't have any numbers up there, how long is one side? We'll just say the top side of that. Austin, how long is the top? Do I multiply A and B if I have two pieces to get that side? I need to add. So everybody good with A plus B? So good job, thanks. So one side is A plus B, and then I need to multiply that by each of the other sides. They're also A plus B, so it really doesn't matter which two I pick to multiply. Boil it. A times A is A squared. Then I get plus an AB plus another AB. And then what's the last term going to be, everybody? B squared, you've got it. So that's the area of the big red square. Now I'm wondering if you would also agree that that is the same as the blue square plus 4 triangles. If I take the blue square and then the 4 triangles that are in the corners and put all of that together, I'd cover the same space as the big red square, right? Are all of my triangles going to be the same area? Little b, little h over 2. And what did we say? Little b and little h, anytime you have a base and a height, they have to make what kind of angle? A right angle. So I've got sides A and B. Do they make the right angle in all 4 of those little triangles? So all 4 of those triangles are the same. So from what you just told me, who can tell me area of the square in the middle, the blue square? Area of just the blue square. One side is c squared, good. So the blue square is c squared plus 4. And we just said little b, little h over 2 would be a, this time times b, because they're the base and the height, and divided by 2. So a squared plus 2ab plus b squared has to be c squared plus 4 times ab over 2. Okay, almost done. What happens with the 4 and the 2 in that last part? They're going to cancel, and we have 2ab plus c squared, and that needs to be equal to our red way, a squared plus 2ab plus b squared. Okay, what do I do now? Ethan, what would you do next to simplify that?
I would put all the ABs on one side and all the...
And what happens if I subtract 2ab from both sides to get them together?
cancel out.
They're going to cancel out. Everybody good with that? Subtract 2ab, subtract 2ab, and they're gone. And everybody, what is left?
A squared plus b squared equals c squared.
And is that what we wanted? So pat yourselves on the back. You just proved Pythagorean Theorem. So it's actually a pretty sophisticated proof. I bet you go home tonight and ask your parents, how would you prove Pythagorean Theorem? How many think your parents would answer? A couple of them. Yes, yours would. And she'd have 4 other ways of proving it too. But if I at any point had asked my parents, they'd not have a clue. Like I said, some do. It depends on their field and their special interests. Everybody's different. But a lot of us, our parents would have no clue. But you guys are really smart. You guys can do that. So let's try a little bit of practice now. We're going to do a couple of things together, and then you guys are going to get to try something on whiteboards to make sure it's making sense. So I need help. Do I have the right shape to use the Pythagorean Theorem?
Yes.
Okay, so how do I set this up? Rachel, you want to give a shot at how we're going to set up our equation to solve that?
So it would be a squared plus b squared equals c squared.
And so what am I going to use in there for those?
We have to use a squared minus c squared equals b squared.
Well, let's stick with the way we've learned it, and then we'll move it around on the next step. You're just ahead of me on it, okay? Your brain's going faster than mine will. So if we take this side, is that one of the ones we can add? And Madeline, what would I add to that? Equals 9 squared. Thumbs up, thumbs down, everybody good with that? The C, whatever the hypotenuse is, letter or number, has to be the one that's by itself. So finish it up real fast, race me. At least getting as far as what a squared equals. Square roots may be a little tricky to simplify. Okay, I gave you guys a head start. And Pascal, what do I get? A squared equals what? A squared first, so they're all caught up. Anybody else 56? So we're good with that. So a squared is 56. Then we want just a, so we need to take the square root. And we always have to stop and think, can we simplify that? How many think yes, it can simplify it? How many think it's reduced? So I've seen a bunch of thumbs going up. So Charlene, what do you think we do to reduce it? Do you have any ideas? Well, my calculator's not going to reduce it. If I just punch in square root of 56, it's going to give me a decimal. And that's not what I want to have. Elizabeth, can you help us? So, one of the ways that we can reduce a square root So we think those numbers that we like. I know the square root of 4. I know the square root of 9. I know the square root of 16, those perfect squares. So I ask myself, can 56 be divided by 4 and get an integer?
Yes.
So 4 goes into 5 once with 1 left, so 4 and 14. That means the square root of 56 is the square root of 4 times the square root of 14, or 2 root 14. Great job. Okay, other thing we want to use Pythagorean theorem for is going to be distance between 2 points. So I'm going to have 2 points here. So let's plot them. 5, 3, 2, 3, 4, 5, 3. Always go across first and then up and down for the second one. -2, -3. So what I want right now is, how long is that line segment? So I'm going to imagine that is the hypotenuse of a right triangle. So I could come down like this and across like this. And are we all happy with that is now a right triangle? And we want to know that hypotenuse. If I know that this point is 2 on the left of the y-axis, and this one is 5 on the right, do I know how far apart those are altogether, everybody? 7. What about how tall it is? Who wants to help me out with how tall that thing is? Okay. 6, 3 above and 3 below. And since it's distance, I'm going to use a D instead of a C here. So let's write down our Pythagorean theorem. Which one has to be by itself? The D, so we're going to say D squared is 7 squared plus 6 squared Caleb, what do those add up to? 85, and then I need to take the square root of that, and that's 5 times 17, and those are both prime, so it's not going to be able to be reduced. And the distance is the square root of 85. So let's write down what we just did so we have a formula, and then we won't have to plot it every single time. So if instead of those numbers, we had x1, y1 is 1 point, could be any numbers in there we want, x2, y2 is another one, and we want this distance right here. Okay, my bottom side is going to be how far apart are the x's, right? How far from one x coordinate to the other one? So the bottom of that has to be x2 minus x1. What about the other side, Emma? This side has to be how far apart the y's are, so how do I write that down? So we did this, how the x's are, how far apart the x's are, x2 minus x1. So this side is going to be how far apart are the y's, and I just have trouble hearing over that fan. So I want to know how far, and the x's were x2 minus x1, so how far apart they are. What do I need for the y's? y2 and y1, huh? So everybody okay with that? So Pythagorean theorem, what goes by itself? So I'm going to write down d squared is, and then I'm going to take one side squared plus the other side squared. But my sides are x2 minus x1, y2 minus y1, and to get just d, I need the square root of that. And that's going to be our other formula that we write down from this lesson. There'll be one more to help with homework I'll give you at the end. So just copy that into your formula list. When you do these, you are subtracting inside the parentheses to make sure you're getting how far apart they are. What's the difference between them? Don't forget the plus sign in between because it comes from Pythagorean Theorem. A squared plus b squared. And don't forget your squares since it comes from the Pythagorean Theorem. And once you've got that copied, you can go ahead and get a head start on this example, and then after this you guys get to show me whether you get it or not with a little bit of whiteboard work. So once you have the formula copied, go back to your notebooks and start trying to plug in what you think goes where. We're going to do it together to make sure we all get it. But while some finish copying, you can get a head start. See if this is making sense or see what you want to be sure you ask a question about. So to start this, I know I need my distance formula. Have you with me? So I'm going to write down D is a big O long square root because that's what I see in my formula. Then I need to take my x's and subtract them and square it. So what are my x coordinates in this going to be? Okay? What do I need to subtract?
2 minus -6.
Okay, so both of the first coordinates, we match those up. 2 minus the -6. And then what goes between? What comes next in my formula? A plus. And then I need to subtract the y's. And Pascal, what do I need to subtract for the y's? So I need to subtract 10 and 3. Doesn't matter if I do 3 minus 10 or 10 minus 3 because I'm going to square it and get the same answer either way there. So 2 minus -6, everybody?
2 minus -6 is 8.
You have it in there. Thank you for answering. I asked everybody. And I only got one answer? Let's try that again. What's 2 minus -6? It's 8. 2 plus 6. So we have 8 squared. Then we have -7 squared. And we're still taking the square root of all of that. So 64 plus 49, what do we get there? 113, and that can't be reduced either. Any questions? Okay, let's check. That's making sense. Are you guys getting it? So grab those whiteboards. First, just a straightforward Pythagorean Theorem one. Write nice and big so I can see it. Hold it up when you have your answer. Don't erase till we check because you want to make sure your work matches what we all did. But hold it up when you're finished so I can give a little bit of feedback. This formula you're going to need on problem 24 that we'll work on together in a moment, and then you'll need it on future problems. It says if you have a circle and you have one point outside the circle, you can draw a line so that it touches the circle on opposite sides, and it touches at only one point. So it just barely kisses the circle on either side. And what's cool in this is it doesn't matter which side you go to, it's the same distance either way. That's the part that we're going to be using in problem 24. But another cool thing, just because I want to make sure you get a fabulous education and get more than your money's worth today, there's another special thing about any tangent to a circle. If you draw the center, and then you draw the radius from that center to that one point where the tangent line just barely touched, you get a 90-degree angle. And of course, it's an angle with a line, because there's no such thing as an angle with a curved side. You can't go to the circle and get an angle. So you've got to go from the radius to the line. You get 90 degrees. Any tangent line you want to draw. So I could draw this one, and the same thing would be true. So this part is a free bonus for today. Once you have that copy down, open up your book. Let's do number 24 and see if we can set that up together to get you started on the homework. So 24 gives you this picture. We've got a circle just barely touching that triangle. So each side of the triangle is a tangent line. They also tell us that the perimeter of the whole thing is going to be 30 centimeters. So the theorem that we just had says if I do this little piece and this little piece, they have to be equal. So we're going to write down A is x plus 3. And you don't have to copy the picture, but I'm going to label that on mine. Okay, who can tell me something about B that uses that very same idea? Rachel? Okay, if I take, and I'll change colors just to emphasize it here, if I take this piece and this one, those have to be the same as each other. So B has to be equal to x plus 2. And finally, Bryce, can you tell me one more thing I know from that picture?
C is equal to x plus 1.
Perfect, you guys get this. That theorem that I just gave you, those have to be the same. So if C is x plus 1, now do you have a way that you can write down everything all the way around that whole triangle, add it up and say it equals 30 and figure out what x is? If you use just the x's now, not the a, b, and c. So you guys go ahead and finish, and then I want you to go on and, for our last few minutes, work on other ones out of the set, and I will answer questions, come around, see how you're doing,